Hi everyone, my name is Samarinas. I'm a third-year PhD student at the University of Massachusetts Amherst. My faculty advisor is Zamani, and today I'm really excited to present a large-scale benchmark to the IR community for proactive conversational IR. So first I want to talk about our vision in our research. So LLMs have changed what we define as query. Current IR models and search engines are not capable of understanding very specific queries that can be complex, and they are not able to also understand long multi-turn conversations. So if we rely only on LLMs for returning responses, this removes the exploration and reliability in a conversational and information-seeking system. And often people don't even know what they are looking for. So here we can see an example of a query on Google. We have a very specific request. We made some Japanese curry dish, and we put too much baking soda inside. So we need to figure out how to remove this bad odor, but maintain the curry taste somehow. And we can see that Google is not able to provide relevant results to this question. The results we get are related to removing the curry smell, which is exactly the opposite of what we want to do. So that's why with our research, we want to make IR models conversational and proactive. So what's the problem? Existing conversational IR datasets are often very small and with very simple conversations. They focus only on reactive conversational systems. That's why we need the large-scale dataset to develop systems that are able to monitor conversations and be able to provide suggestions proactively without user input. And we also need, obviously, a new metric that considers various aspects like relevance and timeliness, when to retrieve documents and what documents to retrieve. So here we can see an example of what proactive conversational retrieval means. So we have a conversation that happens over time across many different utterances, and then we have a model that is able to do two things. First, decide when to retrieve content, at which point in the conversation, and also what type of documents to retrieve. So that's why we introduced ProCIS. So it's the first large-scale benchmark for proactive IR and conversational information seeking. It consists of 2.8 million long-form conversations from Reddit threads, filtered with a lot of steps. It's also linked to a corpus of 5.3 million Wikipedia articles, which serve as noisy labels. And there are also thousands of topics covered in the training set, in this noisy training set, and 100 different topics in the test set. This enables evaluation of both reactive, the traditional retrieval task, and proactive retrieval. And we also have a test set that is carefully annotated with depth pooling with human judgments that include relevant document judgments with 3 degrees of relevance, and also supporting evidence inside the conversations for these decisions. So here we can see an example of a conversation from our annotation interface. On the left, you can see that we have some posts from Reddit and many follow-up comments. And on the right, we have a paragraph, a document from Wikipedia, and we need to decide basically the degree of relevance and provide supporting evidence. And that's how we constructed a very high-quality testing set to complement the very large-scale training set. And here it's the new metric we introduced for this task. Where it's a variation of the very famous NDCG metric. We call it normalized proactive discounting cumulative gain. So the idea is very simple. So basically, we want to penalize when documents are retrieved before the target utterance. And basically, in that case, the contribution is 0. And basically, based on the distance to the target utterance, we penalize the score. And we tried the many traditional baselines, as you can see here. We also introduced a generative LLM-based approach, which outperforms traditional baselines by a big margin in a reactive setting. And we saw that Colbert still performs best in the proactive setting. So some future directions, new model architecture for proactive retrieval, generative IR, pooling and query formulation methods, synthetic data generation, also industrial applications like targeted ads in LLM-based conversational systems, and many, many more. And one more thing, we also have an instruction-based search engine for the SIGIR conference, so feel free to check it out, and it will give you a tiny early glimpse into the future of search. Thank you.